Let's take a look at G-CO.C.9 and also look at the perpendicular bisector and its relationships. Again, in this objective, we're trying to prove or establish some facts about angles, as well as other things about perpendicular bisectors, angles, triangles, things like that. And in this case, they want us to establish a new fact about points that are on the perpendicular bisector. We would like to establish that the distance from A to C and B to C always have to be equal for any point C. This is actually not too difficult using a transformational approach. If I draw in those two segments, I think it becomes a little more obvious what our transformational approach will be. You can kind of see the reflection there that exists now. So let's attempt to prove that AC is congruent to BC. And the approach we're going to take is a transformation, a reflection. And so a reflection over the perpendicular bisector of AB maps. So let's see what it actually does. So like most transformational approaches, we list out what we're going to do, and this is it, and now we discuss what physically happens. So it maps point A onto point B. Now you might say, wait a minute, that's quite an assumption that A lands on B. It's not, because this is the perpendicular bisector of AB, and we know that that is a property of a reflection, that the perpendicular bisector is the line of reflection. And so if this is the perpendicular bisector, A will go to B. It's also true that point C will map onto point C because it's on the line of reflection. So C remains where it's at. A would map onto B. Now remember that we have an isometric transformation taking place here. So it would be true that the original points AC, A and C, will maintain their distance when they get mapped to the new location, BC, because reflections are isometric. In other words, we're going to use a reflection. C went to C, A went to B, therefore AC, the pre-image, mapped to BC, the image, and so they have to be equal because we have an isometric relationship, which establishes that any point C on that perpendicular bisector is equidistant to those two endpoints.